Hello, everyone. So we are going to start our very first chapter here, our first section here in Chapter 6. Chapter 6 is all about exponents. We're talking about different exponent rules. We're talking about different properties of exponents. Later in the chapter, we're going to start graphing different exponential equations. We've got word problems. And our goal is to finish this chapter before the end of the trimester. So it's a little bit shorter than chapter 5. Not going quite into as many details, I think, with as many different processes and all that stuff. So we've got one more chapter test, and then the trimester will be over. So hopefully we feel good, and we're going to go ahead and get started. We are back in our student journal. If you want to hop over, we're on page 170. If you want to take notes in there, it's fine to take them in a notebook. It's a nice thing about a video. You can pause it if you need a second to write something down. I would get these different definitions down. A power, we're talking about in math, we're talking about exponents. A power just means anything that represents that repeated multiplication. So that's just kind of fancy math speak for an exponent. Okay, let's say I've got 2 to the third power. Okay, we've seen exponents before. We should be used to that. The exponent is the little number. Okay, the number of times a number is multiplied by itself, so we should hopefully remember 2 to the third power means 2 times 2 times 2. Right? The base is the number that's being multiplied. Okay, so don't get that mixed up. Sometimes the very first times we go over some exponents, it's been a little while since we really worked with them too much. Okay, 2 to the third. Let's do something else. Let's do 5 to the second. 5 squared. Okay, that's 5. Let's do another color. That's 5. 2 times 5 times 5. It also has scientific notation in here, but I don't care about scientific notation right now. I don't know why it puts it in this chapter. We don't care about it right now. I don't know if we're ever actually going to care about it. All right, so let's move on. Okay, we've got all these different properties. That's what 6.1 is really all about. All these different exponent properties. Some of them you've probably seen before. Some of them might be new, but a lot of them we probably need to review. It's been a little while since we've done these. So the first one is the least intuitive one, the zero exponent. Okay? So anytime we have a number, anytime we have a variable, anything to the 0 power is 1. I always ask, what do you guys think this is? Okay? And everyone says 0. And it makes sense, except it's not true. Okay? Anything to the 0 power is 1. And maybe as we go into some more of these rules, you'll kind of see how it makes sense with the other rules. Okay, if you have x to the 2 times x to the negative 2, how, okay, well, I'm going to combine those two exponents, and I don't have 0, but I have 1. Okay, it doesn't just totally disappear. If it doesn't make sense, don't worry about it. Just remember the rule. All right, negative exponents. All right, so any negative exponent is basically saying take this term, take that term, and put it under 1. Do the reciprocal. Okay, so there's a couple different ways we can see this. We can say, okay, well, let's do it with x. X to the negative third power. That's going to be the same thing as 1 over x. It's going to stay to that same power. Okay, x to the third power. Okay, let's say I had something crazy. Let's say I had something like x squared, y to the negative third, and then z to the fourth. Okay, first off, I know I'm not going to combine any of these exponents because all of my variables are different. It's just like terms. You can't combine an x squared and a y cubed. So I know I'm going to keep those all separate. the y here has a negative exponent. So I know that's going to go in the bottom of a fraction, okay, in the denominator. So I've got x squared, z to the fourth is going to stay. I'm going to do my z like this because they always look like 2's. Okay, z to the fourth is going to stay in the top of a fraction. But y to the third, that's going to go now in the bottom of my fraction. Okay, if I already give you everything, let's say I have 2 to the negative 4 and x to the negative 2. Okay, if they give you something where you have something in the bottom of a fraction with a negative exponent, it's saying it should be on the other side of your fraction. Okay, so if I had this fraction right here, I would know to flip both of these. I would say, okay, well then that x to the negative 2 power, that's going to turn to x squared here on the top of my fraction. And that 2 to the negative 4, that's going to change to 2 to the fourth there on the bottom of my fraction. And I could probably figure out 2 times 2 is 4, times 2 is 8, times 2 is 16. I could probably simplify that to 16. All right, let's move on. We've got more properties that we can learn. Okay, product of powers property. Okay, we've got all these different properties. I really am never going to care what the name of the property is. I just care that you know the property, you know what to do. Okay, anytime that you've got powers with the same base, don't forget that. It's got to be the same base. You can add their exponents. Okay, so this is what you're going to see. You're going to see lots of problems like this. You're going to have x to the third times x squared times x to the fourth, something like that. You're multiplying these things together, but the exponents get added. Okay, because x to the third is x times x times x, right? You have it 3 times. And then x squared is x times x. And then x to the fourth, I've got another 1, 2, 3, 4. I almost wrote 4. 4 x's. Okay, so I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 x's. That's x to the ninth. Okay, it's somewhat counterintuitive because people see the multiplication, they think they need to multiply the exponents. That's not really what you're doing. You're adding. How many times am I multiplying the same base? Okay, so let's see, what type of problem might you see with this? You would have, let's do x squared y cubed times x cubed y squared. Okay, everything with the same base is going to get added together. Okay, those exponents, so those two exponents that you have, the 2 and the 3, they get added together. I get x to the 5 times y, same thing, 3 plus 2, also to the 5th. Right? Now we have a similar one over here, this quotient property. It's basically the same idea, but instead of multiplying these two things together, you're dividing. Okay, when you have 2 here with the same base, now you're going to subtract their exponents. Okay, so here's how I do this. I'd say, okay, I've got x to the 5th over x squared. You're always going to want to subtract. Okay, so 5 minus 2, I get 3. So I'm going to have, since my larger exponent is in the top of my fraction, I'm going to have x cubed. Think of it like it's the top of a fraction over 1. I don't care about that. I'm just going to leave it as x cubed. All right. Since that's where the higher exponent was, you can think of that x cubed like it's the top of a fraction. If I gave you something like z to the 4th over z to the 7th, I'm still going to subtract. Okay, I'm still going to think of, okay, 7 minus 4, that's 3. I didn't mean for them both to be 3. All right, 7 minus 4, we get 3. So I am going to have z to the third power, but it's not going to be in the top of the fraction. See how the larger exponent's here in the bottom of my fraction? It's going to be the same deal. I'm going to have that z to the third, but it stays here in the bottom of my fraction. I'm going to put it under 1. Okay, wherever your higher exponent is, that's where you're going to leave the term. Okay, generally for a simplified answer, they don't want you to leave it. I mean, technically we know from our negative exponent rule, I could say, okay, 4 minus 7, I know that's the same thing as negative 3. But remember what we just learned about negative exponents, that's the same thing as 1 over z to the third power. That is the more simplified version. All right? So be careful with that. A lot of times that negative exponent isn't super intuitive for people. Okay? All right. So we've got 3 more. 3 more. Okay, power of a power property. Okay? When we're finding the power of a power, this is where we're going to multiply our exponents. Okay? So this is when you would see, you're always going to see this with parentheses. So let me draw a little problem here. Let's say I've got z squared. Right? And I'm taking that whole thing and I am taking that all to the 4th power. Okay, when you see, okay, I'm taking this exponent to a power, that's when you have to multiply. Let me use easier numbers here. Let's say I'm squaring it. Or let's say I'm cubing it. Okay, I'm taking it to the 3rd power. That's me saying z squared times z squared times z squared. Okay, and I know I would add all those together. I would get z to the 6th power. I have 3 of these squared exponents. Okay, so z to the 6th is how that one would work. Okay, and I feel like here's a good place to bring up, a lot of times people get kind of confused with their exponents. When we have something that looks like 2x squared, a lot of times I have people asking me, okay, so should I square the 2? But think of this, you have 2 times x squared. That exponent doesn't apply to the 2. The only time it would be if you had these parentheses that said everything in these little parentheses is being taken to that power. Okay? When you have parentheses and then a power on the outside, everything in the parentheses is being taken to the power. Otherwise, it's just what's right next to it. Okay? Here, it's just that x that's being taken to the power. Okay? It's not really part of this property, but that's, I would say, one of the biggest mistakes I see all the time with exponents. I just want you to be careful about that. Okay? Now we've got power of a product property. I would say, for the most part, we don't use this one super often. We definitely use it. I'm going to explain it, but everything above the power of a power, product, quotient, all those you use all the time. This one's just kind of, these two are kind of just nice to have in your back pocket. Okay? It's basically saying if you have 2 things that you're multiplying and you are taking both of them to a power, you can take those things to the power separately. You can say that's the same thing as x squared, y squared. So it helps with simplifying a little bit, right? If you got 2 crazy numbers, okay, let's say 16 times 14 cubed, and you went, oh, I don't want to take 16 times 14 and then cube that huge number. Okay, you could do them both individually. Okay. again, it's going to help you with simplifying, especially as we get into kind of the polynomials where you have a ton of different variables and powers and all that stuff. But for the most part, the other ones are going to be more helpful to you. Okay, same deal with quotient. Okay, if you are, let's say you are, I'm just going to go with x and y again. If you are cubing this whole thing, you can think of that's the same thing as saying x cubed over y cubed, right? I have an assignment for you up in Schoology. I'm not going to do a packet like I did for chapter 5. Most things I'm going to find in the textbook. I think this one might be a worksheet, but for the most part, I think a lot of what we have is going to be just pages out of the textbook. So you can print that out. You can do it in your notebook, but I will see you guys later.